Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to be digging into some Atari 8-bit machines. On a recent second channel video, I tested basically all the Atari 8-bit computers I had in the house, and it turned out there were about 12 of them. Actually, if you can believe it, I found a couple more after making that video, but I tested those off camera, and they work perfectly. Well, these machines are known to be very reliable, and that definitely held true with all the computers I had, because out of all the 12 that I tested, really only 2 had actual problems, and this is one of them. So in today's video, I'm gonna crack open this Atari 400, which has really seen better days, like the door is broken off of it and everything, and I'm gonna see if I can get this thing working. If the repair for this ends up being simple, then I'll jump into the second machine, and if that's easy as well, then I have a third machine which is showing some problems, which I'll dig into as well. But as usual, I'm doing this intro before I've done any diagnostics or any further diagnostics on these machines, so I have no idea if it's going to be an easy repair or a hard repair. So without further ado, let's get to the repair. Now, I'd like to start this video with a caveat that I know very little when it comes to doing repairs and diagnostics on Atari machines. Now, it's an 8-bit computer with a 6502-like processor, so I should be able to use all of the troubleshooting skills that I've shown off on other videos with these machines. I'm not too concerned. So please forgive me with the mistakes I'm going to be making in this video. I'm sure there will be some, just because I'm super not familiar with the way these systems work. I also don't know about or have the aid of cartridges like the Dead Test cartridge for the Commodore 64, which does a lot to help you troubleshoot a 64 that's not working. I'm not really sure there's something similar for the Atari. The later machines, as I showed in the second channel, have built-in diagnostic ROMs, but this Atari 400, which we're going to be starting with, this thing does not have any built-in diagnostics. In the past, I've done some searching for diagnostic cartridges for the Atari, but it seems that all the ones that maybe exist are pretty basic and rudimentary, because as far as I'm aware, on the Atari 8-bit line of machines, the cartridge slot, for it to work, you need to have a mostly working computer already. We would need to have some type of ROMs that replace the actual system ROMs in order to do more low-level testing, and that's something I've just never come across of. And this is probably because Ataris, as we saw in the second channel video, are super reliable. So people haven't put a lot of effort into diagnostic ROMs. Either way, this is the machine we're going to be focusing on, at least at this part of the video. So it's an Atari 400. As I mentioned, the door is broken off. That's a bit of a problem because there is a switch that shuts the power off to the computer when the door is removed. So in order for me to run the system, I either have to place this door onto it or push this button down with a pen or some other instrument. You might notice, as this is an Atari 400, it does not have the membrane keyboard on it. This has an aftermarket replacement keyboard, which actually has keys that move. This keyboard, as far as I'm aware, was something that was readily available and available like in the back pages of magazines and stuff like that, and was a pretty popular mod for owners of 400s, simply because that original keyboard, while decent for what it was certainly hard to type on. And while this thing feels pretty terrible to type on, it obviously is going to be better than the original keyboard that's on here. Not to mention age might have ravaged this keyboard, and maybe it types a bit worse now than it did when new. If we take a look at the bag of goodies that I had attached to the machine, we have, well, the original speaker, which I think I have removed from the computer. That's really mainly for key clicks and stuff like that. We have the spring for the trap door, the top door that is, and then a bunch of plastic pieces that have obviously broken off the case. One standoff, some screws and stuff like that. So this poor case has seen better days, and unfortunately a bunch of the standoffs are broken, and I don't know if that's from the top or the bottom, but it's coming apart. The problem that this actually has, though, which is what I really want to get fixed, is this one: garbled graphics sometimes. So what I mean by sometimes is sometimes when you turn on the computer, you get a black screen, and if you hit the reset button, which is on the top on the keyboard, you'll get garbled screen, and it changes what's garbled. Text is on there sometimes. It's just kind of random what you're getting. So I don't really have any hunches right now on what's wrong exactly with this machine, but I think the first thing we need to do is take it apart and take a look inside. So on the bottom of the machine, things look okay, but this standoff is entirely missing, which I'm assuming is this one that's broken off. All the screws are out of the case though, and I guess that's probably something that I did originally, and it's being held together with this tape. Now this computer was Atari's low-end 8-bit machine and only ever came with 16 kilobytes of RAM from the factory. And it doesn't really have the provisions to be expanded to 48K, at least not officially. I know there were aftermarket modifications that allowed you to go up to 48K, maybe even beyond, but I'm not 100% sure a lot of people did those modifications, because I think the idea would be that you would buy the 800 and that was easily expandable to 48K or offered that way from Atari directly. And then you also automatically got the really good keyboard and audio video outputs. Yes, that's the other limitation on this, is RF out is the only way you can hook this up to your television. Of course, there are aftermarket mods that give you a composite video output, just like on the Atari 2600, but as a cost-saving measure, RF was the only output, at least from the factory. All right, lifting this off, you can see that the keyboard is connected with this pretty terrible looking membrane keyboard, and another key just fell off. All right, so I can kind of see what happened here with the keys, and it's unfortunate because the missing key almost certainly happened because it looks like we have to pop these off in order to get the keyboard out of the top cover. So I'd imagine in shipping, this thing got bumped around a lot, so much so that the key ended up popping off and then got lost. Okay, that one kind of came apart, but that's okay. I'm able to pop the lid off now. There it is. Now, off the top of my head, I don't remember the brand name of this keyboard, but I have to say the design is interesting. So this doesn't appear broken. The slider's stuck on this keycap, the option key, so I'm just going to reinstall it so nothing gets lost. With enough pulling, I was able to disconnect the keyboard. Hopefully that can get that back on. I think this is probably the original connector on the board, the main motherboard that is, that the original membrane keyboard plugged into, and this is just an aftermarket replacement. It says B key or beta key 400, 1982, version 2.1. Since this computer has never actually worked, I don't know how well this keyboard feels to type on. The reset button works, so I know that switch works, and they are mechanical, so that means that you could clean that contact relatively easily by just popping off one of the keys, and they come off so easily, which is obviously why that key ended up getting lost. Now let's talk about the elephant in the room, and it's this very heavy, solid die-cast case that contains all the electronics, the digital electronics that is, inside this machine. What you see on the board here is simply the power supply, the RF modulator, and the interconnections between the I/O ports, and this does have 4 controller ports. Yes, very ahead of its time for 1979, and the SIO port. This is sort of similar to the IEC port on the Commodore, but it is much faster, and it's actually like a precursor to USB. It's very, very cool and allows you to daisy chain a bunch of external peripherals at a good, decent speed as well. Now for the power supply, I presume this is working perfectly because we had video and we had garbage and stuff, but maybe it's not. 9 volts AC enters through the DC jack. There's a bridge rectifier. We have the main power switch, a large smoothing cap, and then I'm presuming we have a regulator, and that's gotta be it right there. It's probably a 7812, hence the heatsink. That's gonna bring that rectified 9 volts down to 5 volts that the rest of this system uses. Don't quote me on that, but I think the memory that this uses is 4116, and that does require some other voltage rails, 12 volts and -5. So somewhere on here, that's gonna be created as well, which we definitely need to check that all those rails are good once we confirm that it is 4116 DRAM that's in here. Now, without a doubt, this giant die-cast case would have been very expensive for them to make versus, say, the Commodore VIC-20 and the 64, which had very lackluster RF shielding. The power supply video board had a couple screws I took out, and I think it's only being held on now by this connector. There we go, I just pulled up and it has come off. There's the little ding-dong thing that allows the cartridge door to push the switch that activates the power switch. So this is what cuts off the power. We have another regulator there. Okay, so there are 2 regulators. Right, so this one here is 12 volts, and this one on the back is 5 volts. I'm assuming there is going to be a -5 volt regulator on the board somewhere, but it may end up being on the main circuit board because that just could be a little tiny voltage regulator because it doesn't really need to carry any current. The RCA jack, which is the RF output, that makes its way over to that connector, which goes to what almost certainly is the RF modulator. And I would imagine on those pins, we have the video and the audio input that comes from the board. Now, natively, the Ataris always output Luma and Chroma, so there's a circuit somewhere, probably on the main board, that combines those together to create a regular composite video signal, which will go into the RF modulator. But we had good video output through RF, so I'm not too concerned that there's any problems with this. Although we might still be missing voltage rails, and that could be causing issues. And it's quite possible that one of these pins, it's hard to see, but there's some pins there that make their way from the power supply board, weren't making good contact. So maybe we're missing a rail on the main board here. Either way, this seems to be free to be removed. So we're gonna do that and get the case out of the way. Now, this is one of the negatives, and I really can't believe how heavy this thing is. Just to run this thing, we gotta kind of all get this all back together, which isn't ideal from a troubleshooting perspective. I need to get the back or bottom cover off so we can look at the digital board and see what those cards are, because it could be we just have a bad connection on one of those cards, or maybe a chip has popped out of one of the sockets. I mean, it just could be as simple as that. That's what's wrong with this machine. With the screws off, this aluminum cover is off, and it's pretty thick. Looking at the underside, we have a little card to prevent shorting, and then the main PCB, and look at that. There's an edge connector there that doesn't go anywhere. I kind of love that. So we do have what looks like two different connectors, maybe one for RAM, one for the CPU, and I think that's the cartridge connector. There's a potentiometer. It's offset from that hole, but maybe that would adjust the tint or the phase of the color. So some of the machines I was testing had text that looked like it was purple, for instance, and I wouldn't be surprised if that is an adjustment you can make by that potentiometer. So I just pushed down there on the cartridge connector, and this top cover came off. And just look at how thick and heavy this is. This thing is outrageous. So on the main board, all of the ICs are in sockets. That right there could require just some Deoxit to fix this thing up. In fact, take a look at the oxidation on these two. So Atari didn't manufacture their own chips. This one's made by Rockwell. These are Signetics, but they did use custom part numbers, which can sometimes throw you off. Although we can see here 6520, that's just a regular CIA or PIA peripheral interface adapter. Probably going to be used for instance, all of the I/O lines going to the joystick ports. Looks like someone here wrote up, down, left, right. Interesting. We have a couple 4051 analog switches. They're in sockets as well. This IC has markings on it that I don't recognize, so this will be a custom Atari part. A quick search with the phone reveals that this is the Pokey chip. So this chip generates sound, but it also, as far as I'm aware, handles the keyboard. Yeah, keyboard scanning up to 64 keys plus modifier bits. Serial I/O, 8 IRQ lines, and it does generate sound. 4 8-bit channels, which I think they're square waves. So just to help me remember what that is, I've written Pokey on it with a Sharpie. So we have a 4050 in a socket as well, plus an LS138, an LS42 also in a socket, and finally an LS10 in a socket as well. Everything's in a socket. Well, if you know your 8-bit machines, you know we're missing the CPU and we're missing any kind of graphics chip. Well, if you're familiar with your Atari systems, these cards that are flapping around in debris, so to speak, pretty sure this one here contains our CPU and our graphics chip. I'm not sure which is which. I'll have to look it up with my phone, but we can tell from the date codes, 1981 is when this computer was almost certainly made. And there is our CPU, 6502B. Very nice. And this is going to be a 74 LS244, even though it has a custom part number. It's almost certainly a bus transceiver. And another 244. And a little searching tells me that this IC is the Antic, and this one is the GTIA, or Graphics Television Adapter. Now, I think there are two types of chips that can go in here, and one is the CI or CTIA, Color Television Interface Adapter, and the GTIA. I don't know which is which and which comes later, but judging by the fact that this is 35th week of 1981, I'm going to wager that this is the later one. So I guess that's the GTIA. Atari folks, comment down below. Okay, so obviously we could have issues with just chips and sockets, or we have issues with the card slots. I mean, these are nice gold-plated things, but you just never know. This thing got banged around clearly. And this is our RAM card. It says 4716. I'm pretty sure that's the same as 4116s, so 400 nanoseconds. And these definitely need 5 volts, 12 volts, and I think -5 volts to work properly. And back on the main board, these 3 chips are obviously going to be ROMs. We'll have to look up exactly the part numbers to figure out which is which. Oh, that one has a 1979 date code. It's kind of interesting. Oh, so does this one. 38th week of 1979. It's odd that these are so old versus, say, this IC or the ones that were on those cards. All seem to be a bit later. Interesting. All right, so we have our lay of the land. A few things I need to remember is that the cards, the chips are facing away from me. So I don't want to plug these in the wrong way. That would be very bad. So first thing I need to do is we're gonna try to get this thing assembled and hooked up to video so I can at least make sure the fault is still happening. And then I think the next thing to do is just do the regular troubleshooting steps. I'm getting set up with a VCR so I can plug this thing in to do capture, and I was trying to plug in the RF output, and using normal RCA cables, it just wasn't working. And then I went and looked at the original, and it's all stubby. So you can't use a regular RCA cable because the little pin is longer and just hits the PCB, so it just won't go on. Ridiculous. All right, so I have the power supply board connected with a little bit of strain relief there. There is the VCR. So wait, what happened there? Okay, well, I don't know. Let's turn on the console, or computer, that is. All right, we're getting black screen. I don't have the keyboard connected, so there's no way for me to even reset it, but that's a good sign. We're getting a correct video output. I know it just looks like a black screen, but if I turn off the computer, you see we get static there. So turning it back on. Okay, now we're getting a gray screen. So you can tell that the VCR is actually working as I'm hitting play, and there's no tape in here, so it's saying insert a cassette. So definitely that gray screen is coming from the computer itself. Let's power cycle it one more time. Black screen this time. Gray screen. Okay, good. So the computer's not miraculously fixed, because that would be my luck that it would be. Now I have to figure out how to try to probe the voltages and stuff that are on the RAM. I think I can do that from the back side. Okay, on the RAM board, pin 1 is right there on that notch. So that's pin 1. We have several different rails: VSS, VBB, VDD, and VCC. So VSS is typically 0 volts, and it is, and VCC is the 5 volt rail. VBB, which is pin number 1, -5, VDD is +12. So we have -5, +12, +5, and 0 volts. So it's flipped. So there we have -5 volts, 12 volts on the bottom pin. That pin right there should be +5 volts, and that is ground. Power on the system, the power light is on. So we're going to get ground right there off this pin. So this should be -5. Yep, -5.25, that's totally fine. This should be 12 down here. Yep, 12 is looking good, and this one over here is 5 volts. And it is 4.94, so we validated that our voltage rails all look good on here. Now you might remember that when I had the keyboard connected, I was able to actually reset the system, and resetting it would just cause the garbage to change, but that implies that that button was working and the entire reset circuit is working. It's still worth me double checking that the reset line on the CPU is actually working properly, so let's do that now. Oh, and look at that. We're getting garbage on the screen right now. So that's kind of interesting. It's very random. If we turn the system off, and I'm going to pull out the RAM card specifically. Let's turn it back on without RAM. And now we just get nothing. But this is kind of what we had before. So just reset the power a few times. Yeah, who knows? So for the pinout on the CPU, I have to do a little bit of checking just to make sure this is a normal 6502. It is a Signetics variant, and it has a B after it, but looks like this is a standard one. I was always under the impression the 8-bit line of computers used a Sally CPU, so a 6502 variant called the Sally, but it looks like that one is only used on the later XL and XE line of machines and not on these original ones. So this is a standard 6502. So that's great, because if it's bad, I have plenty more of those. I can replace this bad CPU. But also it means the pinout is not different. I assume the Sally has some extra capabilities that is used on the later machines that just isn't used on these early ones. Now for a computer like this to work, the CPU needs critical things: 5 volts, a reset line that's not stuck, and a good clock signal. So even after all these years, I don't remember the exact which pin is the clock in. It's 3750 in, and pin 40 is reset. The fact that it has a line over RES tells us it's an active low signal. So when the signal is at ground, that means the CPU is in reset. Oh, I forgot to mention, the reason why this is turning on right now is because I have the switch for the cartridge door taped down. Otherwise, we wouldn't even get any power on the system. Luckily, there's a convenient power LED that comes on, so I can tell that it's working or not. Okay, so I have my scope probe, and I think we're all good to go. We're at 1 volts per division. I am on pin 37 now, the clock input. That just does not look right. Not at all. Let's make sure I am actually probing the right pin. I am not probing the right pin. Okay. And that's because the notch on the CPU is facing down. So pin 1 is there. Okay. now I'm oriented correctly. Whoops. Okay, now I'm on Phi 2. Okay, I think this machine runs at like 2 megahertz or so. And I think those gaps are intentional. So, okay, yeah, 1.78 megahertz. I think that is correct. And I think the gaps have something to do with maybe the video refresh or something like that. Okay, now I'm on the reset line. Yes, definitely. It pauses before it goes up. Okay. And you see how it fades down? It's probably a capacitor handling the reset circuit. So like it charges up and then it goes high. And that brings the system out of reset. Okay, that looks normal. All right, now I'm on pin 37, which is the clock input. That is Phi 0, and it's going to look the same as Phi 1, or Phi 2, I mean. It will have those gaps, yeah. Okay, all looks good on the clocks. Well, like my shirt says, I think the next step on this machine is to deoxit that socket and do that on all of the socketed chips. At least I need to kind of pop them out and push them back in, especially on those ROM chips that have the oxidation on the pins. Then let's see if that is the fix for this machine. I'm just going to start by giving everything a push, because some of these are, yeah, those are kind of out of the sockets quite a bit actually. And sometimes pushing them in is all you need to do to break through that oxidation layer. Wow, yeah, some of those were pretty loose actually. And on this board, it's not as bad. Oh, that chip was like half out. Interesting. And then these ones on the main board here. All right, so the 2 cards are done and these 3 chips. Let's see if that made any difference. What happened? Got power, but I'm not getting any video. So our problem appears to be worse than it was, because now we're not getting any video. Let's just double check the VCR here. Oh, the VCR was off. Okay. Ah, okay. We're getting scrolling, but it's not better. I assume we're gonna get randomness with black screens. Yes, okay. Okay, let's keep going with the pushing on these chips now. The ROMs were not loose in their sockets at all. Pokey, those chips, those were kind of loose. Okay, how about now? Nope, no improvement. One thing I'm noticing is the power switch is very flaky. Interesting. So we had good stable rails when I was measuring on the RAM card, but just moving that power switch around, the LED sort of flickers there. So I put some Deoxit in there. See if that's any better. Yeah, I think it is now. It's not so touchy. Got cool patterns. Because the ROM chips are looking especially bad, I'm just gonna pop these out next. Okay, so it's interesting. These 2 sockets were normal double wipe sockets, but these are evil. These are really bad, junky sockets. I hate these. So flood that with Deoxit. This chip looks good though, the one that was in there. No oxidation or tarnishing on the pins at all. And no change at all. Okay. Same exact symptoms. I'm gonna put some Deoxit on this edge connector next. I'm actually gonna do it on the CPU card as well. Ah, that was interesting. I mean, I don't think this is really indicative of anything, but we had like a kind of a garbage pattern that cleared. Kind of feels like the reset circuit did that. Like that garbage was maybe just there initially when you first powered on, and then, yeah, like the reset made it do that. The problem we have here is that it's very difficult to scope and troubleshoot with these cards in place, especially with the RAM. But the ROMs are just sitting here. So I think I need to get the oscilloscope out and we're gonna take a look at all the data lines and address lines on the ROMs. We need to see if anything is stuck, for instance. I'm also unfamiliar with which chips can be removed from the system and still have it working. Like, can I take the Pokey out and the 6520 and have the system still operate normally? I'm just not sure. Pop out 6520 and let's get the Pokey out. Now I do have some spare chips sitting here. I don't know if those spares are any good. But since everything on this system is in a socket, it's not too difficult to do like the old parts cannon approach and just start swapping everything. Okay, so Pokey's out, 6520 is out. Let's see what that does. Okay, that's interesting. Quite different. Oh, now just a gray screen. All right, so things definitely are looking a little different. I'm going to pop back in the 6520. First, we'll put that in with some Deoxit. Oh, very garbagey. That's without the Pokey in. Part of me has to be wondering, is Pokey doing reset? Because this looks like we have no reset, if you ask me. Okay, so I went to console 5. I don't know if this is the best place for these schematics. Let's solve the ICs, capacitor list, and then we have schematics. All right, so I'm looking for schematics that are easier to read, and whatever was on console 5, which is this stuff, doesn't seem to have all of the stuff anyways, missing like the CPU card and whatnot. Probably has only enough for recapping, because I think console 5 really focuses on that. So this one seems to be pretty complete. This looks like a recreation too. The text is very clear here. So looking at the block diagram, on the CPU card, looks like the CPU connects to 244 for the address lines, 2 of them. The data bus lines, on the other hand, look like to be directly connected to the ANTIC and the CTIA, and then goes down to the motherboard. Clock generator, which we can assume is looking okay, 1.79 megahertz, is on the CPU board as well, it looks like. Looks like the read-write line from the CPU passes through that. I don't quite see any connections to Phi 2. That's the clock output from the CPU, so I assume it is not used. CTIA takes an oscillator input on the main board. That's for color carrier for NTSC. That's working fine. Control switches, trigger lines, video signals come out, speaker output. Video control goes between the ANTIC and the CTIA. Same with that clock signal, the color clock that is. All right, so that's helpful. Refresh is coming from the ANTIC. That's refreshing the DRAM. And there's the 6502. Phi 1 not connected. Phi 2 not connected. Okay, it's definitely not used. Reset line pin 40. Where is that going? I just want to make sure. Oh, that goes right onto the motherboard. And it looks like reset A and reset M. So MPU or CPU gets its own reset line separate from the ANTIC. Right, and here is the 400, and this is the motherboard's block diagram. So master clock goes into the CPU board. There's the RAM board, the personality ROMs. Those are the 3 ROMs that are on the motherboard. There's a decoder, which I think is the LS138. So that I need to check that to make sure that it's selecting the ROMs and the RAM and the cartridge slot correctly. Pokey's handling the keyboard plus the paddle lines. I want to see if the Pokey's handling reset because it looks so different when we pull the Pokey out. Joystick controller, that must be those 4050s or 4051s or whatever they are. And they go to the PIA, that's the 6520. Output of the CPU board, so the GTIA is illuminance and color information, which gets combined with the video summing. That goes off to the power board for the RF modulator. That's this J107. And there's power on reset, so that does not come from the Pokey. That's a separate circuit that goes right to the CPU. Okay, that is as much as I can zoom in. It is blurry. It is blurry. All right, here it is. It's on the second page. Yeah, pin 25, there's the reset circuit for the CPU. There's a little capacitor that charges and a little op amp or whatever that handles the reset. And it looks like the ANTIC reset is just tied together and it probably goes off to the keyboard, which, yeah, I bet you whatever, that connection probably ends up going to the keyboard. Oh, no, here it is, reset. So this is from page 2. I think this is the, yep, that's the 6520. So that needs to be reset as well. So where's the keyboard connection to the reset line? I'm clearly missing something because the keyboard has a reset button and it definitely connects to this somewhere, but where? Incidentally, the edge connector on the back of the motherboard I thought was an extra connector is this, test points. So all of this stuff goes to there. So it's much easier to actually test these signals. That was nice. So looking at the keyboard connector, these lines are obviously for the matrix because this goes into the Pokey chip. But then there are these extra signals that go directly through some resistors right to the CPU card. Non-maskable interrupt, S0, S1, S2, and S3. I wonder if the reset button is actually just doing a non-maskable interrupt and doesn't actually pull that reset line down. So these S lines, I think, come from the keyboard. They go into the CTIA or GTIA, and along with the R and MI line, that goes into the Antic, and the Antic is hooked up to the CPU through the non-maskable interrupt line. So I don't think the reset button on the keyboard actually pulls that reset line down. I think it's doing something with these chips. All right, so I have a few different ways we try to approach this repair. I can obviously start probing around all the address and data bus lines. That's easy enough to do on one of the ROM chips right here. I can grab another Atari 400 and I can borrow the cards from that, and we could try them in here one at a time, see which one of them makes the system work. Or I have a set of chips that the viewer sent in, and there should be a full complement of the 40-pin ICs that go in this machine, and we could try these one at a time until we figure out which is the problem chip. Or I could use something like a Retro Chip Tester Pro to take all the RAM out one at a time, test those, or any of my RAM testers. And I could use the Retro Chip Tester Pro to also dump the ROMs, the 3 ROM chips on here to see if those are working properly. The problem with the methodology I just mentioned of like Retro Chip Tester Pro or swapping chips or cards around is if you need to have spare parts. If you don't have any spare parts, how are you going to solve the issue on your Atari 400 if it's broken just like this? So because of that, what I'm going to do next, I'm going to put the pokey back into the machine with Deoxit, of course. And we're going to start taking a look at the address and data bus lines just to see what we see there, see if anything looks out of the ordinary. So if it does, then we can try to track down which chip is causing the problem with the address or data lines. Because when those are not working, the whole system is not going to work correctly, maybe like it's doing right here. All right, first step, I need to just make sure that it's not broken. The VCR shuts off. That's interesting. That's what it's doing now. That's what the pokey reinstalled. So nothing got fixed by taking out these chips and putting them back in with Deoxit. And it's weird because that static just does not look like what we were getting before. So something seems like it's changed. Let me just make sure I haven't bent any of the pins on the chips I just took out, because that's always a risk. When you take stuff out, put it back in, you can bend pins. No, everything looked fine. I didn't see a single bent pin or any other issues, so I don't get why it's behaving a little bit different now. What I'm going to quickly do, because I haven't done this yet, so I'm just going to feel around for hot chips. Everything is super cool to the touch, not even warm at all. And on the CPU card, everything feels perfect. What I'm going to do is pop out the CPU card and I'm going to feel on the RAM card. Oh, interesting. Of course, there's no graphics. Without the CPU card in, you won't get anything on screen. So that's why it's just blue, but the power is on. RAM chips, nice and cool. Every single chip on this machine runs nice and cool. Okay, put the CPU card back in. Back to our wild static that we never had before. I'm just going to move things around, push on stuff while it's running. All right, so I flipped this around so I have access to the CPU for easier probing, and I'm going to use my test clip just to make this a little bit easier for working on camera and hitting those points. There are test points available on this edge connector, but it's not clear from the schematic like what's where, and I think they're double-sided, or some of these contacts are different on the bottom side. So I think ideally there was probably some kind of a harness that plugged into this during manufacturing, or maybe the service center had something like that. With the clip on the CPU, it's going to be very easy for me to look at all the pins. So we're going to start on this top one, which is A11, pin 20. Let's turn on the computer. Looks normal. Excellent. Well, I don't know if that's normal. I would say that's not quite enough activity for things to look normal, but I just want to make sure that we're seeing activity on all of the address lines. So address line 10 looks fine. 9, okay, that could be a bad connection. I think that was a bad connection. I was about to say it looks weird, but I think that's actually okay. That's address line 8, address line 7, 6, 5, 4, 3, 2, 1, 0, which is pin 9. The next pin should be VCC, 5 volts, looks good. The sync pin, whatever that does, I don't even know what that pin does, I forgot. Then we have non-maskable interrupt. Interesting, we're getting interrupts. Now remember, this actually comes from the Antic chip, if I recall, and it's obviously sending an interrupt to the CPU. Then we have not connected, and then we have the interrupt line itself, which has stuff happening. I think this is phi 1 out, so it should be 1.7 megahertz. Yes, it is. So that looks fine. And then this is the ready line. It's not really doing anything. And ground. Okay. So everything looked really good coming out of the CPU. Now we have to remember the address lines are connected to some 244s on the CPU card. So I need to check both sides of those to make sure the address bus isn't corrupted on the computer side. But first let's go through the rest of the address lines. So address line 12, 13, 14, 15, data line 7. Now this is unbuffered. Gonna say that's probably okay. Let's zoom in a little bit. 6, 5, 4, 3, 2, 1, 0. I fell off the pin, but that was 0. I'm assuming that's the read-write pin. So normal activity, not connected, not connected. And now we're at the clocks, which we know are good. We already looked at those. In fact, I need to start from the bottom again. So reset looks good. Phi 2, SO. All right, so everything on the CPU looks totally fine. Don't see any smoking guns there. Now I need to check out these bus transceivers. You know what? I think it's probably easier for us to look on the ROMs that are on the motherboard. I'm sure they're the same pinout as 2364. So we have all the address lines, which are the ones we got to look at. We already looked at the data lines. Let's look at the address lines. All right, so I have another clip on the ROM chip. This should be address line 7. Pin 1 looks okay. Address line 6, 5, 4, 3, 2, 1. Uh-oh. That's not good. Okay. I don't know for sure if the pinout of what I'm looking at on the picture on the web page here does match the chip exactly, but I wouldn't be surprised if it does. So this should be ground. Okay, it doesn't. Because that pin, which I thought would have been ground, is up at 5 volts. Okay. Yeah, one of the reasons why I was trying to use a different pinout is because what's on the schematic here is very hard for me to read. The font is super fuzzy. I want to look to find that pin. This one. That looks messed up. All right, so we're looking at pin 7. Address line 1. Well, that looks bad. Let me check that signal on this other chip next to it. 1, 2, 3, 4, 5, 6, 7. Okay, looks the same. The address line and data lines go between all the ROM chips directly. There's no actual difference except for the chip select lines. So that pin looks bad. So let's go to these 244s, and it was what? Address line 1, right? A1. So it should be pin 5 on Z303. Z303. 1, 2, 3, 4, 5. And the matching pin is 15. So pin 15 is the one closest to the CPU. That should be address line 1. And the one that looks bad is the one that I've marked there towards the edge of the board. So let's probe the pin towards the CPU. Okay, I think that's address line 1. It should be at least. Okay, and that's the other pin. It's not doing anything right now. It's sort of stuck. I'm going to power cycle the computer. Huh. So that's the pin on here that looks bad. 1, 2, 3, 6. Interesting how it's doing something on the ROM chip, but on the bus transceiver, it seems to be stuck. But what I can tell you is that the pins below and above it look fine. So that is, I don't know, the pin right next to the problematic one. And then that is the one that is problematic. Okay, good. We've actually found an issue here. Excellent. That little bit of blip there was from me touching the pin next to it. Okay, so this is really good. We figured out that that address line is messed up on the computer side. Now what's causing it, that's what we need to figure out. So what I'm going to do is pop out this chip, since it's in a socket, And I'm going to bend that pin out of the socket itself so that I can measure it with the scope when it's floating, so we can look to see if it's trying to drive the bus correctly or not. So I just use my little chip lifter tool to bend the pin gently. While I'm at it, I'm going to deoxit that socket. I hate this kind of socket. They're the worst. So the chip's back in there, but the pin is floating. So if I measure this once I power up the system and it's driving the bus correctly, well, that's telling us that something else on the computer is keeping that address line at that level. I mean, it still could be this chip is bad. Maybe the driver is blown out, but I doubt it. System is powered on. Wow. This driver is bad. It's not driving it correctly. How interesting. So let's pop this Motorola part out. Luckily, this is like the most ubiquitous type of chip there is. Here's a replacement, 74LS244. So it's installed. Will that fix the machine? First things first, we'll turn this on. And I will check the address lines again. No. Something is still wrong. Did that chip fail? Because something is holding that up at 5 volts. Okay, what I want to do is check continuity. Wait a second. So I'm not getting continuity, so I think I am making a mistake somewhere. So the schematics say that pin 5, which is address line 1, should make their way to, of course, somewhere on here. There it is, that pin right there. So the address lines come from the CPU, they go into this buffers it, it goes to these two chips and it makes its way down to the motherboard. That pin right there. Okay, so that makes its way to this test point, which I'm gonna draw on with a marker just so I can remember where it is. So this test point here is our problematic line. And it has to be going to the ROMs. It just has to be. Oh, it's over on this side. Oh, I realize what's happening. Pin 1 is right there. I thought these chips were installed the opposite way. Okay, so that's the address line that's problematic, which should be address line 1. Okay, so obviously if we turn on the system, looks fine. That looks fine. There was definitely a problem with the chip I took out, for sure. I was measuring the pin out of the socket and it wasn't working on that address line. I just was doing it wrong on this chip here. We still have stuff on here that looks messed up. These two lines, I gotta figure out what they are. So all of these look fine. I think these are data lines. Oh, unless this is chip select. It could be chip select lines, now I think about it. So that means I stumbled across that bad address line coincidentally. Let's just see if the system is even working right now. I gotta turn on the VCR. Got a black screen, looks like. Okay, black screen. So it's still not fixed. It looks just as bad as it did before. Yes, okay. Actually, you know what's really funny? Going through the pins, the ones I thought were bad on the ROM, they're now showing activity. It's this one. This was the line. See how there's like a little bit of activity up at the top and then it goes down? Red herring. Okay. Whoops. Okay, just to make sure that I'm not making a mistake, I'm taking out this 244 and I'm going to put the original one back in with the pin back in the board. I just want to make sure that, you know, I wasn't mismeasuring because I'm all upside down when it comes to which chip is where and all that stuff. And conveniently, I have it marked on the PCB where that signal is. No, it's fine. There's nothing wrong with that chip at all. Okay. So that, my friends, is what I call making mistakes because I was all turned around on the orientation of the chip in the board. So I'm just checking all the pins on the ROM now. Yeah, that one's high again, but I think this is a chip select line. So if we turn the system off and on, yeah, okay. Normal activity. That's a rule that I should have remembered. Whenever you see a line that looks stuck, turn it off and on, the computer that is, just to make sure that it doesn't kind of come good like it did right there. Okay, good. So I'm glad I didn't desolder any chips. These 244s I got out of stock, I don't need. The one that's on there, of course, is actually okay. And I bet you right now, because we saw a lot of chip select activity, I bet you we have garbage on screen. And we do indeed, lots and lots and lots of garbage. It feels like when there's no chip select activity, we have black screen. But when there's that weird garbage on screen, the ROMs seem to have a bunch of chip select activity, which would be coming from the LS139, which I think is something I need to check next. Now I'm talking about, we go back to the main schematic and we zoom in and look for the chip select lines. There they are, CS. These are coming from this IC, which, gosh, that's hard to read. I think this is an LS42. And some of those lines are going over to whatever this card slot is, and the other ones are going to that card slot. It says RAM on that one. So I guess the fact is it's, well, there's enough chip select lines for 48K of RAM, even though this system only has one slot, so it only can accept one of those. This must be the CPU card slot over here. And I'm assuming those chip select lines are for the Antic and the GTIA, I'm assuming. So I think what we need to do is just take a look at the outputs of this IC. 1, 2, 3, 4, 5, 6, 7, and 9, it looks like. It's gonna be easier to look at the data sheet for the chip. So A, B, C, D, that's the input, and the outputs are 0 through 9. Okay, I'm on pin 1, which according to the schematics is the S0 line. So if we turn this on, is at 1.7 megahertz. It's like the clock, basically. It's coming out of that S0 line. Okay, S2, pin 3, just high. Pin 4 looks high. Now S4, which was doing stuff. There we go. I don't know, it looks okay. But that's not a chip select line. That goes over to the CPU card, it looks like. S6. It's a little low all the time. Oh, there we go, some activity and then it stops. And now we have chip select lines. Now it is weird that these two ROMs, these actually have the same chip select lines. Oh, I see, 2 chip select lines. You see this one here as chip select low, this one's chip select low, and chip select high. So it alternates between these two ROMs based on, I guess, address line 12. And when you have 2 chip select lines, it's not as cut and dry. It's just like, oh, this chip's enabled all the time, like with the PLA goes bad. And that's because, for instance, this chip select line 20 is low right now, which means this chip should be on, but it will only actually be on when address line 12 is also high. So I'm on pin 7 right now, which is feeding to this chip, and it's low, which normally would be, oh, it's selected all the time because it's not doing anything. We power cycle the machine. I don't know, it's not really going up and doing anything. But ideally, this chip's not turned on unless address line 12 is high, pin 21, which when we look at address line 12, pin 21 on that chip, it's high, which means it's turned on. That seems weird that it's selected all the time. That just seems not right. I'm not blaming that ROM chip as the problem, but something funky is going on here. So this is 105. Which is the chip on the left here. 104 is this one. So this chip looked like it was selected all the time. I mean, maybe it's worth checking this LS42. I just popped it out of the board there. Well, I just looked through all my 74 LS chips and I don't think I have a single one of these BCD decoders, these 42s. So let's use Retro Chip Tester Pro to test this IC. I have a feeling this chip is totally fine. Yeah, it's fine. Okay, not a problem. It's just, I don't really know how it's supposed to look in an operating Atari because I don't really have that experience. Just popping that back in there. Not surprised at all. There is no issue with that chip. So I think, unfortunately, at this point, I'm gonna have to resort to some chip swapping. So looking at the spare ICs that I have, first one's a Sally. So this is a CPU that's not compatible with this. So we can't try that. But I have a Pokey and an Antic. And these are 6520s, each of these, so I don't think those are the problem. So let's start with the Antic. Well, I hate this kind of troubleshooting because I'm just taking shots in the dark. It's quite possible there's a bad RAM chip. It's possible any of these custom ICs is bad. I mean, there are so many possibilities here. So, yeah. Okay, so the replacement Antic is in the board. Okay. It's not the Antic. And if I take the pokey out, I vaguely remember we had no change. Or maybe we never got garbage without the pokey. I can't remember. Let's just put the other pokey in. I don't even know if these chips work. These could easily be bad as well. Okay, new pokey or other pokey. No difference. Well, that's it for my custom ICs that I had as spares that could work in here. I'm pretty sure the 6520, that doesn't matter at all. In fact, just for fun, we'll take this out of the board. We'll leave this out of the board because I'm quite sure that is not necessary for operation of the machine. Just in case, we'll put this RAM card back in and we'll give that a test. Same thing, gray screen. Okay. Now I have the Retro Chip Tester Pro out. A couple things that we can do with that. It can actually test the ROMs, and I think these three should be testable in there, even with the weird chip select lines that those have going on. It can also test this type of DRAM, but I have another tester, and this can test 4016 DRAM as well. And you might be wondering what's the tape? Well, I have that on there because, of course, this is for 4116, and if you put a regular RAM chip in there, it will damage it. So I'll pop in this 4016 I just had laid off to the side, and we'll test this first. So this plugged in through USB. We'll push this. If these come back, well, it's blue. It's hard to see, but they're blue. And I think that's telling us that this is working, and it is a 16 kilobit DRAM by 1. So if we pop this out and we try to run a test, right away we just get red. It's hard to see because it washes out the camera, but this thing is working. So I'm going to go and I'm going to test this DRAM real quick just to make sure that it's all working, and that'll just help kind of rule out that we have an issue with DRAM. Okay, so this is weird. This came back as an 8 kilobit DRAM because only 2 of the lights are lit. So I just popped in the next one. All right, so that came back as the same thing. What's going on here? Now looking at the datasheet for the part, it's an HM4716-4. And according to this, that's 16 kilobit by 1 DRAM, so same as any 4016, like the first one I tested. But why am I only getting 2 of the lights on the tester? Okay, so what's frustrating here is this DRAM tester I was sent by a viewer, so I didn't buy this, and therefore I don't have the original listing for it. I think these came off eBay. And I remember that I once found like the instructions for this tester so I could figure out what the different lights meant, but I'm not seeing it on eBay right now. And I know this tester was made by Simon Raybould. So here's a PDF, I think the instructions for a different version. Hopefully this is close enough to the one I have. Okay, so there are the LEDs. This is kind of what I thought. When you have 4 blue lights, it means 16 kilobits. We're getting 2, which would indicate half the RAM is bad. For parts with a capacity up to 16 kilobits, such as blah, 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 bunch 4116, each LED represents a 4K block arranged as followed. 4K, 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 4K. If it's a 64 kilobit chip, like a 4164 from a Commodore 64, you get 4 green LEDs. And if it's a 256 kilobit chip, you get purple. So we're getting that, which shows up as a TMS 4108. That is literally how it's currently lit up after testing 2 of the chips. That doesn't make sense. I could see one of these chips being bad, but having 2 be bad in exactly the same way seems extremely unlikely. What? That one just comes back as totally bad. So let's just test that one more time. All red. I know it looks like orange, but believe me, it's red. Okay, so let's just quickly test these again. So this one should be 2 blue lights instead of 4. 2, yep, so that's 8 kilobits. And this was the very first chip in the RAM card on the far left. This one should also test, it should be 4 LEDs, but we're getting 2. Oh, okay, so that one just came back as completely good. It's definitely the one I took out of the Atari though. Nope, now it's only testing with 2. And these chips are in really good shape. There's no kind of corrosion or anything on them. If I grab the RAM chip that I took off my sideboard, which is all oxidized, as you can see, give this a test. And when we initially ran this, this came back perfectly with all 4 LEDs. There it is. That is how it should be. So far these first chips come back as bad. I mean, those two show up as 8 kilobit. The third one shows up as totally bad. Let's try the fourth chip. Okay, that one came back as good. So this one I'm going to put an X on. These I'm going to put dots on because they're sort of suspicious. But this one looks fine. I'm going to give it a silver dot. We'll just run it one more time. No. Now it just came back with 2. And this could easily be some kind of a fault with this RAM tester though. Well, so far this third chip definitely shows up as red. That's totally bad, red. So this one seems like it's bad, and it's probably making a mistake about these others. So we're gonna pop these back in, except for the bad one. The one that's testing with the red lights. I'm gonna put the 4016 that I had off to the side. I'm gonna put that in that socket. I'm gonna put number 4, which I think is okay, back in. Okay, we got 4 blue LEDs for that. So that one seems okay. Okay, we're getting like the 2 LEDs. So it's just half lit, but I'm gonna give it a dot anyways. Okay, same thing. Half lit, but I still give it a dot. And the final chip. All 4 are lit there. All right, so there's the RAM board now. That was chip number 3. This one here definitely tested bad. Now you might be wondering, why was this keeping the system from booting? Well, with a 6502 processor, the 0 page and the stack is both held in main memory. And most of the time, the developers, when they come up with the ROMs on these machines, they use the 0 page and they use the stack to make more compact and efficient code. If you don't use the stack, for instance, you can't really use subroutines because you need to be able to jump back to where you were, and you're using the stack for that. Not to mention 6502 doesn't have that many registers, so you're using the stack to push registers onto and off of and stuff like that. And so a lot of times when your memory is bad, right away execution crashes. And depending on how memory is bad, if it's bad in like random ways, the machine will crash in weird random ways. Now this is where diagnostics like DesTest Max or Dead Test Max or the Apple II Dead Test ROM that my friend David came up with help. Those are coded in a way that it doesn't rely on your main memory at all for operation of the computer. So for the Atari, what would be really helpful is some type of a ROM that you could maybe pop into the motherboard. I don't think the cartridge would work, but have to be something that would execute immediately at power up, that could then initialize the graphics subsystem and display some text on screen to say, okay, you know, I'm alive, I'm running, your computer is working, and now I'm going to check the memory and see if the RAM is good. And if the RAM is bad, then maybe somehow display that and tell you, which bit is bad or whatever. So this third chip over might be data bit number 2, for instance, or maybe it's data bit number 5. Who knows? Either way, that ROM could potentially tell you and then give you that pointer to say, hey, it's this chip. Now, luckily, the memory on this thing is all socketed on at least this Atari 400. But it's possible that later models of Ataris, that wasn't the case. And in that case, you're going to be desoldering a bunch of chips and risking damaging your system. And well, there's, all sorts of issues when you take chips off. So it's very helpful if you have a diagnostic ROM that you could pop in, for instance, and that would then give you the indicator to help you figure out which is the bad chip. According to the tester, this chip is bad. Whether this will actually fix the computer or not, who knows? Not to mention all this RAM was sort of showing sometimes bad, or sometimes 8 kilobits versus 16. So if the system is still not working, I'm probably going to go and just replace all this memory with known good 4116 memory that I got from somewhere else. But I've had a lot of issues with testers, including the Retro Chip Tester Pro, but this one as well, where it'll say RAM is maybe marginal or not good when it is good, or vice versa. It'll say it's good when it's not. But usually when it's quick to say something is bad, like this one chip, and the rest kind of are all showing the same thing with that half 8 kilobit thing, I'm more likely to trust that it's this chip that's bad, and the rest of these are probably fine. All right, so with all that said, the RAM board is back in the system. We are running back on the original Pokey, the original Antic. All original chips are in here. Oh, except the 6520 is removed. Let's turn on the system and see what happens. The VCR shut off, of course. Okay, weird. We're getting a rolling image. Huh. Okay. Not fixed. Well, I'm going to put back in the 6520 just in case this is definitely required for the system to boot properly. I can't imagine that's the case, but I don't know much about Ataris. No. Still not freaking working. All right, well, that leads me back to this. let's take out one of these chips that was doing the weird half thing, try it in the Retro Chip Tester Pro, and we'll also try this bad chip in there. Let's see what that does. Okay, bad chip is in here. Okay, right away that failed. Let's do it again. Let's see if it tests and fails at the same location. Yes, address 41. Okay, bad, bad, bad. Okay, let's take one of the other chips out, the one that was testing 8 kilobits sometimes. Let's see what happens now when we run the test. Huh. This one failed as well. Let's see if it fails in the same location. Yeah, 3C. I accidentally exited out of the test, but yeah, it was failing in the same exact spot both times. Well, these aren't MT RAM, but it's possible we just have a whole bunch of bad RAM. Yeah, 32C8. So there's an option here for DRAM pull-up. Let's just turn that on. Sometimes that can make a difference. Nope, failing exactly the same way. Okay, so that was chip number 1. Let's try chip number 2. So I have it configured to do both March Y and March U testing and random testing. It's kind of doing all the DRAM tests. It's very slow when you turn them all on, but it's at least comprehensive. This is Hitachi DRAM, made in the USA, incidentally. It doesn't have a date code, but I'm assuming, you know, it's from the early 80s like the rest of this computer. Okay, that chip, good. Okay, this is the 4th chip, since the 3rd chip is the one I already swapped out. Let's test again. And so far we have one extra bad chip. That one passed as well. So I'm just going to go through the rest of these and figure out if any others don't pass the test in this tester. All right, all the rest of the chips passed. So really it was just that first chip which showed as potentially bad. So I popped in another one, and let's see if that makes the difference and makes this thing potentially work. Okay, VCR is on. Nope. So we are still not at the root of our problem. We are getting exactly the same symptoms that we were having before. I am curious what happens if I put a cartridge in though. Let's pop in, I have a minor 249er here. Okay, so let's see if that makes any difference at all. Oh, it's weird, it's kind of glitchy now. All right, I'm totally stuck. I think I'm gonna have to grab another Atari 400 and I can start at least trying the 2 different main cards out of that one, or putting these into the other one just to see where the fault lies. If it's the motherboard, or is it actually the RAM card or the CPU card? Now, if you have an Atari 800, one thing that's cool is there are 3 RAM boards. You can take out 2 of them and swap them around just to see which one is the problematic one. The first 16K of RAM has the 0 page in the stack. That's the part that needs to be there for the system to boot. The rest, it doesn't matter. So you can definitely pull those out and swap-a-roo. And actually, before I take apart another 400, let's use the Retro Chip Tester Pro to see if we can test these ROMs and see if they match the database on the SD card, so I can at least rule out that the ROMs are the problem. So I'm not sure how large these ROMs are. Like, what do I put in here? 2332, 2316, 2364. Looking at the schematics, the ROMs have address lines 0 through 11 on them. So if we add these ones into the binary mode for address lines 0 through 11, that tells us these ROMs are 4 kilobytes each. Well, of course, these are in kilobytes, so we just multiply that by 8. This will tell us how many kilobits it is. And that tells us right there that these are 2332 or 32 kilobit ROMs. So on the next screen, it's asking us about how the chip selects work, low or high, and to be honest, I don't know because it differs from one chip to another. So what we're going to do is jump to detect. There's an auto detect mode. We're going to try to use that. Okay, low is 20 and 21. We'll hit OK. There it is, Atari 400 NTSC. So I guess the ROMs are different maybe than the 800, but anyways, it is detecting it, and we'll do that again. And we happen to know that it's low, low, this chip at least. And there we go. And it's looking it up by a little database that's on the SD card, by the way. Some people ask about that. And if you have one of these, you just go to the website, and this is from MAME. So you can download the database there. Okay, so that first chip does appear to be totally fine. So I'll put a little, okay, whatever. I was gonna put a little dot, but that is good enough. I don't think the ROMs on the Atari are particularly failure prone, not like the ones on Commodore 64s. So I will use the auto detect on this ROM again. Low, high, okay, so it is different than the other one. Let's see what this one is. There we go. Atari 400 NTSC, so that one's good as well. And our final one? Not possible. Okay. Is this chip bad? So the way this auto detect works is it just tests all the different chip select permutations for 20 and 21 until it's able to read data out of the chip. Doesn't appear that that's the case for this chip. And I can look at the schematics, I can tell A105 chip select 21 is high and 20 is low. So 21 high and 20 is low. That's what matches the schematics. Ah, it's bad. Do you see that? How it's like, looks like half the chip is working. Okay, that could be a bad connection. Let me just double check what's going on here. So this chip here, the pins are in pristine shape. It's the other ones that have kind of a tarnish on them. This one does not have any tarnish. So let's try that again. See how basically half the chip comes back as blank. That's what those little empty squares mean. And I was just double checking the schematics. This definitely has all the address lines hooked up all the way through address line 11. That is hooked up to this. Okay, so what do we have so far? We have a questionable ROM and 2 RAM chips that seem bad. It's questionable whether these are really bad because again, the tester told us they were bad, not the system. So these might be fine. But this ROM, that could really explain kind of what's going on. So I'm going to leave that ROM out. Let's turn on the system like this and just see what happens. Okay, turn on the VCR and right, same kind of thing. Rolling picture. Okay, so normally you'd be like, oh, we'll just put an EPROM and then you could replace it. But the issue is this chip, the one that's bad, it's this one all the way on the right side. It's got chip select low and chip select high. Well, on EPROMs, that's a problem because if we look at the same size EPROM as this, a 2732, well, it has 2 chip enable lines. We have output enabled that needs to be low, and we have chip enabled that needs to be low as well. Not to mention address line 11 is hooked up to pin 21, while address line 11 on the original chip is hooked up to pin 10, it looks like. And pin 10 is one of the data lines. So a 2732, not a good fit. How about the TMS 2532? I can't remember if this is a better fit. Yes, this is a better fit, but not a perfect fit. Because again, the problem is 21 is VPP, 20 is PD or PGM. PD, what's PD mean? Okay, so for reading this chip, basically the program pin goes low. So that is the chip enable line. So the address says they're set up, then you enable that, and then basically a little while later, this whatever interval, then the output comes out of the chip on the data lines. Now here's the problem. There's only one chip enable line on this EPROM, and it's pin 20. 21 is just the VPP pin. That has nothing to do with whether the chip is enabled or not. But when we look at the Atari, it's using these 2 chip select lines very specifically to only enable that ROM at the appropriate time. So in order to use even a 2532, which is almost pin compatible, we would need to use some extra logic to ensure that pin 21 is high and pin 20 is low before the chip is actually turned on. Now we do have another possibility. What about replacing both the middle ROM and the rightmost ROM chip with a 2364, and then we only need to rely on this chip select line from pin 20 here on both of those chips, and that would work. And then address line 12 would be the extra address line necessary for the 2364. Yes, I think that might do the trick. And if we look at a 2364, yes, that works because look, pin 21, address line 12, it's already hooked up that way, which is exactly how it is here. Address line 12 goes into pin 21. Perfect. So believe it or not, a 2364 would be drop-in compatible into either one of those sockets and replace both of those chips. Now for testing this, I actually have a little adapter right here, which allows you to go from a 2364, so that's on these pins, and it goes to pretty much a normal EPROM on the top. So a 2764 or even a 27128 works fine. And in fact, I know I use this thing with a 2864, and that works as well for easy testing and programming. So let me get this all set up and let's see if that makes this computer work. All right, I think I've run into an issue. I don't think this chip is actually bad. People watching probably were screaming at their screens. Even though the schematics show all 11 address lines are hooked up to all 3 chips, it appears that the chip that I think is bad is actually like a floating point library. And when I went and downloaded the ROMs for the 400, it's only a 2K file. And remember how this thing only looked like it was half there? I have a feeling it's actually a 2316 and not a 32. And I couldn't tell you why it's all hooked up this way, but I suppose the memory map accommodates it. So I bet you if we go back to the Retro Chip Tester Pro and we set it to 2316, this chip is going to work fine. So I've switched over to 2316B, and I think this is correct, where address line 11, I'm looking at the schematics, address line 11 is pin 18. Yes, okay. So we're going to do the auto detect, and yep, it auto detected fine here. There it is. The chip is fine. It's a 12399B, which is exactly what I had downloaded. Okay. So I'm going to take the paint mark off of this because that is actually a good chip. It is not a bad chip. I'm glad I didn't go through all the effort to, you know, make EPROMs and stuff like that. I already have this adapter. This would work. It would work to replace those. You could use one 2364 in place of both of these. But that means that we have another fault on this board. So I'm just going to put a dot there because I checked all three of those. In fact, we've also swapped out the Antic with one of my spares, one of these chips here, and that was okay. And we also did the Pokey, so I'll put a dot on that. So what we have left, really, is the GTIA, the CPU, some of these logic ICs, and the 6520. Like I said, I don't think it's 6520. We do have spares of those. Let's just, for the fun of it, swap that out. Having done no work on the Atari, I just don't know what it works without and what is required to be installed in the board. Okay, 6520 is installed. Turn it on. And of course it's not going to work because the CPU card is not installed. So we'll pop that back in and try again. Yes, still not working. Just as I suspected. Pretty sure that that chip, of any chip, is not going to be necessary for the system to actually run. Well, I'm definitely learning things about the Atari architecture here. It's not like I've solved the issue, but I'm learning things. I'm still learning things. That gets a dot. Right, so at this point, it's time to grab another Atari 400, and I need to swap the two boards here, just one at a time, and see if either of these two cards fixes the issue, or if the problem is isolated to the motherboard. So for testing the CPU board and the RAM board, I could take them out of an 800 or a 400, and both of them are a bit of a pain to take apart, but the 800, the RAM cards are really easy to get off. Those just come out of the front of the machine without having to take it fully apart. So let's first try this RAM board and see if that makes this thing work. And while we know the RAM itself on this board should be good, obviously there's other logic chips on here that could be problematic. So this came out of an 800 that is known good and working. So we boot the VCR. No. Definitely not working. Now I gotta take apart the machine the rest of the way. All right, there is another Atari 400, and this one definitely works. So of course the main thing I want to test is the CPU card, this one right here, as this has two of the chips we were unable to test so far. So first we're going to put the original RAM card back in with the tested memory, and here's the known good CPU card. And is this going to fix the machine? Here we go, 3, 2, 1, and that fixed the machine. So it's one of those two main chips, either the CPU or it's the GTIA. I suppose what we should do is I'm going to pop in the basic cartridge here. Well, let's let this thing boot up into basic, and I want to put those two RAM chips back in, the two that we've been having issues with. Okay, there's basic, it says ready. Okay, so I just put in the one that was testing all red in that one RAM tester, that first RAM tester. Will the computer still boot? No, it will freaking not boot. So that bad chip is definitely, most definitely actually bad. So I just popped back in the RAM chip that we originally had in that position, the one that was allowing this computer to boot. Okay, it's still booting, good. And there's one more chip to put in. This was the one that the Retro Chip Tester Pro said was bad, but not the other tester. Well, the other tester said they were all kind of bad. But that chip was bad in just the Retro Chip Tester Pro, and there we go, it still boots to basic. I wouldn't be surprised if there were some subtle RAM errors that might show up as crashes or other strange issues. It was higher up in memory. The memory error on that first chip happened very low down, definitely within the 0 page. So just for safety, I'm still going to change out the other chip, but it's interesting how this machine 100% had a bad RAM chip, and it resulted in that weird pattern that we were seeing before as well. As in, originally, that's what we were seeing. Remember when we were getting those rows of text? Okay, so now the question is, where's our fault? Is it with the CPU or is it with the GTIA? And I guess the question is can I just use a normal 6502 in here? Let's just try that. I actually have one sitting off to the side, and maybe I should have tried that originally. Okay, here's a Rockwell 6502 from 1983. Pulling the CPU out actually damaged the socket. So hopefully I can get this back in and undamaged. Oh yeah, it's fine. Okay, so I have no idea if this can actually work, regular 6502. Let's give it a try. Okay, here we go. No. Well, maybe. Could be the graphics chip as well. Okay, so this is the working card, the GTIA chip. Now I'm kind of going off the assumption it's this chip that's actually bad, and well, I mean, we already know that that chip is not the problem, right? That the 244, and I really think it's unlikely the other one is the issue either, only because I looked at the address lines on the scope and they all look totally fine. Now the issue might be the CPU that's causing the issue because I have this Rockwell chip in here, but let's just try this GTIA chip and see what happens. Is it gonna work or not? No! Let's go back to the other CPU real quick. Okay, the original CPU from the broken machine is back in. Wow, it's still not working. Did I do something wrong here? Yes. Yes, I had the Antic chip in, one pin off on the socket. Let's try that real quick, now that I have it in correctly. And look, it booted up. It freaking booted up. Color's wrong, but that's where this knob should fix it. Yes, much better. Okay, well, let me go back to this aftermarket CPU, or whatever, non-original CPU, because I'd really like to know if a regular 6502 will actually work inside one of these original Atari machines. Okay, here we go. Yes, it does. Okay, good to know, good to know. We know that the original CPU is actually good though, so it gets a dot. So Antic is good, original CPU is good. These logic chips all appear to be good. And not like I've done full suite of tests on here, but I'm sure these chips are all fine. And at least at the minimum, this AMI chip made in Korea, this appears to be the one that is bad. This RAM chip here, this is one of the ones we know for sure is not working. It causes the whole computer not to work. And then this is the marginal chip, which I just don't trust. So I'm going to leave this with a big old X on it. So 2 RAM chips and a bad GTIA chip. Now I have questions. Will the system boot with the 6520 removed? I bet you it will. Yes, boots fine. Next, will it boot without this FPU ROM? This is the 2K ROM I thought was bad. Will it work? Yes, it works without that as well. I bet you BASIC doesn't quite work properly, but at least the system turns on. Let's get the BASIC cartridge installed, see what happens. Says ready, even with that chip removed. Now this is the OS itself. I have a feeling it won't boot with either of those removed. So let's just take one of these out, and it's probably not gonna work. But black screen, yes, black screen. Okay, now what happens if we put in a game like Miner 249er, which I'm pretty sure does not rely on the system ROMs or whatever. Yeah, it's still not gonna work. Pretty sure the system ROM boots the system, initializes everything, and then it kicks off whatever's on the cartridge. Just for completeness, let's pop out the other of the 2 ROM chips. Oops, that didn't work out so great. There we go. See if that results in a working system or not. Non-working system. Figured as much. I think both of those are definitely required for operation of the system. Okay, next question. What if we take out the Pokey? Ah, okay. At least it kind of initializes. We don't even get the ready prompt because I guess it's looking for the keyboard or whatever to work, but at least you get a screen. What if we pop a cartridge in? So this is a game cartridge. There we go. It loads. Yes. Okay, so if you have a bad Pokey, take it out. It's not really necessary for the system to run either. Next question, what if the RAM is removed? There's no way it's gonna work now. black screen. And obviously with the cartridge in, it's going to be exactly the same. It's just not going to work. Yeah, black screen. It needs the RAM for the 0 page and the stack or whatever to initialize, at least with these built-in ROM chips. Okay, there it is. We don't get the regular prompt because the pokey is missing, but as you can see, it's working. Quite sure these chips are not necessary. I think it's for the joystick ports. Those probably work fine without the pokey. Those aren't even doing anything. I know that on the CPU card, you definitely need the GTIA and the Antic chip. Those together are necessary. You need the CPU. You're going to need 2 or both of those 244s. And I think the other logic chips over here, like this middle one, what I thought was bad, you absolutely definitely need that for a working system as well. And at least on the 400 and 800, you can use a normal 6502 CPU from like a Commodore 1541 or a VIC-20 or whatever, and that's good enough to have a working system as well. All right, pokey's back in, 6520 is back in. I'm assuming we should get a prompt. We do. I learned some great troubleshooting tips here. Now, the question I have is, was it already common knowledge that you could take out the pokey and the 6520 and the floating point ROM and still have a working system? Maybe. I didn't really see anything about the minimum viable configuration for the Atari and what you could kind of do without just to eliminate those as potential problems. Right, so we've identified bad GTIA, 2 bad RAM chips, or maybe 1.5 bad RAM chips. Now it's time to do more testing on this computer. I gotta play some games, make sure the sound is working, the keyboard works, joystick ports work, and then I can call it good, and then we'll do a conclusion. Some time has passed, and since I ended recording, I did end up using this machine quite a bit, playing a bunch of games, including Miner 249er, which I gotta say is a pretty fun game. And this computer now seems to be working perfectly. No glitches, no issues whatsoever, other than the RF looks a little soft, totally working perfectly. I even have the keyboard reconnected and I'm able to type all the letters and they all work perfectly. So this keyboard is working flawlessly. In addition to playing with the computer and validating it works well, I've also edited up all the footage that I recorded during the fixing of this machine. I do that typically because since I make my videos completely unscripted and off the cuff, occasionally I'll forget to include something or I'll need to go back and clarify a little bit of information. And in this case, at the beginning of this video, I mentioned diagnostic cartridges and that I didn't have one. Well, turns out I actually do. A viewer gave me this Super Salt cartridge. It's a replica of an official Atari diagnostic cartridge. I guess apparently around 2012, these were uncovered, dumped, and now these recreations have been created. And theoretically, this might allow us to run further diagnostics on this machine. And I'm really curious to know about this cartridge. Will it work if the computer is missing components, like if the RAM is missing or if this bad GTIA chip is in there? How useful is this cartridge when the machine is really not working well? Now, this is the cartridge that's easily available on PCBWay. You can have a little PCB made up, but apparently it's just a pretty standard cartridge. You just have to download the ROM. You can find it on Atariage and stick it onto any cartridge. What's really funny about this is I don't know which way this should go into the cartridge slot. I don't want to put it in backwards, and there is a message that says this side will be placed in the same direction as the Atari connections. Well, that message really makes 0 sense when it comes to the 800 and the 400, because on this machine, the connections are all on the right side and on the front. So you would think you would put the cartridge in that way. But that is incorrect. It turns out, and maybe if you are in the know about Atari stuff, if you open up one of these Atari cartridges, the ICs and the chips are all on the back side. So if you look at the front of the cartridge, this is the part that faces towards you with the label, it's on this side where all the chips are placed. So the way this Super Salt cartridge should work would be installed into the machine like this. Well, to help me in the future, I've gone ahead and I added a P-Touch label that says cartridge label side, just to tell me which side of this PCB is the equivalent of having the label side in the actual full cartridges, because it's really easy to know which way to put these in. You always put the label facing you, or if it's on the side of the machine like the 1200, the label faces up, or on I think the 600, I think it goes like this with the cartridge on the back with also the label facing up. Either way, with the power turned off here, let's get this inserted into this Atari 400 and let's look at what this does and see if it's going to be useful. I'm going to start removing chips from this and we'll see when this cartridge stops working. All right, so Atari 600/800 Super Salt System Test. I think SALT stands for Standalone Test. I think it's telling us this is an error because this ROM appears to be the version that is only for the 600 and the 800, and it doesn't really recognize the 400 versions of the ROMs. Let's put the question mark here and see, help. Okay, well, let's just try all of these here. A, for any video or analyzed video maybe. I guess you're just supposed to know what this is supposed to look like, and you're like, oh, that looks good. Okay, we'll try collision next. So I know on the Atari, sprites are called player and missiles. I don't think it uses like the standard terminology like a 64 might use. Okay, so that looks okay. Gray color. Monochrome mode, I suppose. Port test. Port test fail. My assumption is there's some kind of harness that connects to all the ports and maybe loopbacks or something like that, and it's able to do a diagnostic. Let's try RAM test. Testing 16K user RAM. It says the test has passed for the RAM. Not surprised. Let's try the tone test. Okay, so it's obviously checking each of the 4 channels on the pokey chip. Okay, voltage. Voltage fail. Who knows what that's supposed to do? Maybe there's, again, some kind of a harness so it can accurately test the voltage. I cannot imagine normally the Atari has a way to sense what its voltages are. Okay, ITIA. So the GTIA, which I'm pretty sure is what's in this machine. Oh, I guess it's just telling us which one it has. Oh, ITIA, identify the TIA. Got it. Adjust. Adjust what? We just have black screen. Impact test. Does this like really stress the bus, I'm imagining? Like maybe constantly changing what's on the screen? Or are you supposed to hit the machine while this is running? That's the only thing I can think of. Okay, well that's all we really have. At least this has the ability to detect the ROMs if you have the ROMs that match the diagnostic ROM. Now I saw online there were versions of this for the 1200, there were versions for the XL machines. I think there's a version for the XE machines, like the 130 XE. Maybe there's a separate version for the 400, but clearly this one is not that. Because if I hit OS ROM, it just says fail. So I want to start taking things out of this machine. I'm going to pop out the RAM card. Let's see if this thing can even initialize without RAM installed. I highly doubt it. No. So you have to have working RAM for this diagnostic to do anything. So what I did is I swapped back in this first chip. This is the one that was marginal with the Retro Chip Tester Pro. And let's see if this can detect that that is a bad chip. So we hit R for RAM test, so it passed, and that's with the slightly dodgy chip in here. How about with this RAM chip that wasn't working on both of the external testers? And this is the one where the system won't even boot into BASIC or the notepad, so I have a feeling it's not gonna boot at all. System error code 5. That is actually kind of helpful. So keep in mind, if you see system error code 5, I think it means there's a problem in the 0 page or the stack, which definitely there is with that bad RAM chip in there. That's kind of cool. That actually means that it's a little bit more useful than I thought it was going to be. I thought it was going to be kind of useless. All right, I just popped out the 6520. Let's see what happens now. I have all the working RAM back in the machine though. All right, doesn't seem to indicate there's any kind of issue. My assumption is the port test, which failed anyways, is still going to fail. I mean, the joystick ports were working. I was using the joystick ports, they were fine. It immediately fails. I think that's what it did last time as well. Okay, so that's not super helpful. All right, I just popped out the pokey chip. Let's see what happens now. Well, it still boots up, and obviously the keyboard's not working. Now see it has just question marks? So if you're trying to diagnose your Atari and you're just getting a whole bunch of question marks immediately when you power it up with this test, maybe because your pokey's bad, that's what you get. Now popping out the CPU card, it goes without saying that without the CPU working, there's no way that this diagnostic cartridge will do anything. How about if we pop out the GITA, and I pop in my known bad one. Let's see if this cartridge would have helped me test and diagnose this thing before I knew that that chip was bad. Wait a second. Wait a second. I don't understand. How is the computer working? I am super confused because GTIA, this chip's not bad? Wait, what's happening here? The colors seem off. That bottom part was green with the other chip. Is this thing really flaky? I think that looks the same. Well, the collision test passes. Let's adjust this knob to try to fix the color. Huh. This chip, without a doubt, last time I had it in this machine, was causing it not to work. Now remember initially when I was testing this computer, sometimes we get the black screen, sometimes we get kind of rows of text, and later after I was doing a bunch of on and off testing with it, it got to the point where we get kind of this weird scrolling and static looking stuff. It felt like something changed at that point, and that happened when I initially took out the Pokey chip, but I put it back in and then it still was acting the same. I'm wondering if this GTIA has a marginal issue in it that sort of manifested itself after I had been running it quite a while. And the original problem with this machine was simply that it had bad RAM. Because remember when I put this bad RAM back in, while I had the known good GTIA in the machine, the pattern that we were seeing on screen looked the same as the initial symptoms this computer was having. It wasn't all static, it was just like rows of text that were kind of garbled. So it really has me thinking that this chip is potentially marginal or the socket is bad. Well, it is weird though, because I took it out and put it back in a bunch of times and it never really got better. And this chip in this machine always worked fine. Or maybe it's a socket that's bad, but no, I don't think it was, because it was acting up with that static before I even took the GTIA out of the board. It was always in that socket. I never even removed it. And even after I figured out that this chip worked in this machine, I swapped them back and forth and the machine was definitely not working with this chip. Well, but you can see right now that it's working. I'm just feeling the chip right now. It doesn't feel specifically hot at all. It feels normal. Feels similar temperature to the other ones, just warm. Maybe I should hit it with some hot air, and I can also hit it with some freeze spray. We can see if either of those cause it to kind of misbehave. Let's heat this up a little bit. I have the heat gun set for 250 Celsius, so it's nothing that's going to damage the chip. Okay, so it's warm. It's not burning hot by any means. I can just keep my finger on it, but it's pretty warm. Okay, let's see what happens if we turn on the machine now. Still freaking working. Let's pull out the super salt just in case it's not booting properly into basic. No, it's fine. Weird, just weird. I edited all the repair footage and this GTIA was 100% not working properly at all. And it was doing that before I even removed it from this board, and swapping this one in fixed it. So I couldn't tell you what exactly is going on. And the only strange thing is how that knob needs to be adjusted to get the colors looking correct, you know, to match this one. But maybe that's normal from one GTIA to another. Well, you know, incidentally, I just noticed that this key has been kind of wobbly and it looks like it's actually broken. Yeah, the mount in there looks like half of it's missing. It doesn't look like the slider itself is damaged though. It looks like it's simply the keycap. Yeah, that doesn't really go on there properly. I think what I should do next is I'm just gonna leave this on the impact test. That was that flickery test. I'll let this run for a while just to make sure that, say after an hour, this machine hasn't stopped working. Well, it's been about an hour and I've been playing games on this thing, using it, and I have the bad GTIA in there and not a single issue whatsoever. Sound is working, joystick is working, keyboard is working, everything is working. So I find it extremely curious that this chip, which I swear was not working yesterday, now works fine. Which is great actually, because that means this computer is fully fixed, at least until this thing goes bad again. And I'm just gonna write bad with a question mark. So if in the future this machine ever misbehaves, that will hopefully give someone an indication that that might be the problem chip. It's now time to just try to reassemble this machine, and I have a little surprise. This is the door that was broken off on this machine, and I've actually glued it back together in a way that I think is gonna work. So you can just see it's a little bit shiny right there. So I ended up having the little pegs that went to the door. They were in the little bag, and I used some acetone to plastic weld it back together. I think it's gonna work. And on the bottom cover, this standoff was broken off, and I did the same thing, acetone welded it on, and I think it's gonna work as well. Now on the top cover, things aren't so great. That standoff is fine, that one is cracked, but probably works okay. This one's missing entirely, and I don't have that, and this one is mostly missing, and I don't have the pieces for that either. So even though this looks better now that I've cleaned it up, it's never really gonna be perfect because of, well, the broken standoffs. So I'm gonna put this thing back together so we can at least see it fully reassembled. These are the extra parts that I'm going to stick inside the computer. So both the bad RAM chips, the extra key, bits of plastic, and one screw that I have that can't go into either of these holes. And I realize now why the option key actually pulls off the slider. It's because in the past this has broken and someone glued this together. So the slider can't possibly come off the keycap anymore. Anyhow, there's the machine all back together, and yep, it seems to be good. The button is pushed when you close the door. I just have to be very careful with it because I don't want to break these hinges off again. But this thing is back together. It's just the front two screws that are missing. So I'll probably just put a little bit of tape around the front corner here just to hold the case together. Because if the case lifts up, it will pop these keys off. And I don't want to risk damaging this keyboard any further than it's already damaged. I'd say the last thing to do before I put the tape on the front corners, let's just power it on, make sure this thing is working. There it is, looks good. Now if we swap over to Miss Pac-Man, there we go, that looks good. Start, yep, perfect. All right, well, this machine is working. I am really surprised that GTI chip sort of came back to life. I cannot explain why yesterday it totally wasn't working and now it's fully functional. If you have any thoughts as to what happened there, definitely comment down below because I really don't know. I'm really glad that that chip is good because I didn't have any spares and I didn't want to sacrifice that other Atari 400 to fix this one. But now that this chip is magically working, the other machine is all back together and it works, and now this machine is all good too because 4016 DRAM is easy to come by, and yeah, that's all I needed to get this thing working. Now I know this video has been really long, but I hope that it's been useful for anyone who is trying to troubleshoot their 8-bit Atari machine. I learned a lot about these machines, like what the minimum viable configuration is to get these things at least showing something on screen. And I found it interesting that the Super Salt cartridge, if I had actually found this right off the bat, might have told me right away what was actually wrong with this machine, which was bad RAM. Remember when we put this thing in, I think it said code or error 5. Not sure if that relates to which bit is bad on the RAM card, but that's actually possible. If you happen to be watching this and you know more about the diagnostic codes that this thing gives, definitely comment down below. But at least for me in the future, if I ever plug this in and get that yellow screen with just an error code, then I know I'm going to go look for the DRAM. Without this cartridge in there and that bad DRAM chip, we got that garbled screen, which is what this computer was doing from the whole time. So this cartridge is pretty useful. And if you need to buy one of these yourself, they're all over eBay. Lots of people are selling these. So I recommend you pick one of these up. It seems to be kind of helpful. As for this machine, I really was going to relegate this to a parts machine. I didn't think I'd have a GTIA to get this thing working again. And I thought the case was in such terrible shape that what was the point of trying to fix this thing? But now that I cleaned this up and I did the plastic welding on those broken parts, this thing is actually a decent little case. And I think that's really going to be it for this video. Now that I have all this Atari repair stuff fresh in my mind, I need to go work on the other broken Atari, which is an 800 XL. I can see it sitting right there. If I leave too much time between this repair and the next machine, then I'll probably forget a bunch of the things that I've learned in this episode. So it's better for me to do that repair sooner than later, just to kind of reinforce everything I've learned by working on this machine. So that is going to be it for this very long video. If you found this interesting, I would appreciate a thumbs up. But if you didn't, you know exactly what to do. Huge thanks to my supporters. Their names are scrolled beside the screen to make it possible to do this full time. You know, all the usual YouTube junk, subscribe, etc., etc. And so that's going to be it for this Atari 8-bit repair episode. Stay healthy, stay safe, and I will see you next time. Bye-bye.